In this capstone, you'll turn ZK knowledge into judgment. You'll evaluate a rollup or privacy product across architecture, security, privacy, market fit, and design trade-offs. Then finish with a recommendation stakeholders can actually use. We've built the pieces: scaling pressure, ZK-rollup mechanics, privacy limits, compliance trade-offs, and adoption strategy. Now we'll bring them together around one practical question. Is this product sound, useful, and responsibly designed? Use this framework to keep your evaluation balanced. Begin with the architecture, what the system is, how it works, and where the key trade-offs sit. Then examine privacy and security. What data is exposed, protected, trusted, or vulnerable? Next, test product fit. Who has the problem, and why would they adopt this solution? Finally, make a recommendation by connecting the evidence. The strongest capstones show how technical choices and product goals support each other. Before judging any ZK product, pin down what it is trying to do. A rollup built for cheap payments should be evaluated on cost, throughput, and user experience. A privacy protocol needs questions about confidentiality and compliance. An identity app depends on trust assumptions and verification quality. Start with the claim, then test it against measurable goals. Turn the system into a component map. Ask where user transactions actually run: an EVM environment, a custom VM, an app-specific circuit, or off-chain compute. Trace what proof is produced and why: scaling, privacy, or selective disclosure. Identify where final settlement happens and how assets move through the bridge. Then check data availability. If data is not reliably available, the security model changes. Once the component map is clear, follow one transaction end-to-end. Look at the user experience: wallet prompts, signatures, fees, and submission. Ask who sequences transactions, how ordering is decided, and whether censorship can be challenged. Trace proof creation: who generates proofs, how quickly, and at what cost. Then confirm where verification happens and when settlement becomes final. This turns abstract architecture into concrete risks and user-facing trade-offs. Data availability answers a basic question. Can users and validators get the data needed to rebuild the chain state? Keeping that data on Ethereum gives strong guarantees, but costs more. Moving it to an external layer or using a Validium model can lower fees and increase scale, but adds trust assumptions. Settlement is the other anchor. Where are disputes, finality, and withdrawals ultimately enforced? Ethereum settlement is powerful, but bridges and upgrade keys can still become critical security dependencies. A bridge is more than a transfer feature. It defines the asset's trust model. First, identify the bridge type: native, canonical, third-party, fast liquidity, or app-specific. Then trace the failure path. How are deposits verified? How are withdrawals proven? Is there a challenge period or emergency exit? Also check who can change contracts, who supplies liquidity, and what users experience when messages fail or assets are represented ambiguously. Treat every privacy claim as a question, not a guarantee. A ZK proof may hide the sender, amount, receiver, or identity attributes, but other signals can remain public: timing, contract activity, deposits, withdrawals, fees, and proof submissions. Ask how privacy is applied. Is it default or optional? Partial or complete? Most importantly, is the anonymity set large enough that users cannot be singled out in real behavior? Security review starts by separating proof soundness from system trust. A valid ZK proof does not protect users if a sequencer can censor them, a prover goes offline, a bridge is exploited, or an admin key upgrades verification logic maliciously. Map every trusted role, then ask what happens when it fails or behaves badly. Look for credible exits. Can users recover funds, access data, and leave safely during an emergency? If not, the risk is still real. Privacy can break without exposing transaction contents at all. The key question is, who is watching and what side signals can they combine? Timing, gas patterns, IP addresses, wallet reuse, and deposit or withdrawal flows can connect actions across apps and chains. A strong privacy review names the adversary first, then tests whether protection is automatic or depends on perfect user habits. Mitigations like relayers, batching, stealth addresses, account abstraction, and larger anonymity sets all aim to reduce linkability. A ZK product needs more than elegant cryptography. Begin with a specific user and their existing workflow. Name the pain that is urgent enough to change behavior: fees, settlement time, privacy, compliance, or interoperability. Compare the real alternatives users already trust, such as rollups, exchanges, sidechains, or databases. The key question is simple: does ZK create a necessary advantage, or is it expensive technical branding? If it does not, adoption stalls. Even a technically elegant protocol can fail adoption. Readiness means checking the full path from first contact to sustained use. Can a user set up a wallet, bridge funds, understand fees, and recover access? Can developers integrate with reliable SDKs, audits, testnets, and analytics? Can institutions meet compliance and reporting needs? And does the market have incentives, liquidity, partners, trust, and a clear reason to choose this product over alternatives? Your capstone should end with a clear decision, not a vague summary. Choose a stance: adopt, pilot, monitor, redesign, or avoid. Connect that stance to evidence from the architecture, privacy, security, and product fit reviews. Be explicit about risks, assumptions, and unanswered questions. Then recommend next steps, such as audits, user testing, compliance review, architecture changes, or market research. A strong memo turns analysis into accountable action. You now have a practical evaluator's lens for ZK. Connect architecture, privacy, security, product fit, and adoption before trusting any claim. Ask whether ZK solves a real problem better than the alternatives. Then keep applying the framework. Compare ecosystems, track upgrades, assess privacy products, and inform product or investment decisions.